Okay, you guys, so we're going to give this a go. This is going to be chapter 7. I'm going to go over some of the stuff that I put online in the Word document and PDF for chapter 7 through, I think, like the first several slides, maybe through like slide 21. So what I've got on the screen here is kind of a summary. We're talking about reactions that happen in aqueous solutions. And aqueous means that it's been dissolved in water, right? So remember when we had talked before about trying to figure out what products were actually going to be formed? This is where you're going to be learning how to do that. And they're using an example with potassium chromate, which is aqueous, adding it to barium nitrate, which is also aqueous. See, I was having trouble getting the superscripts also. I think I figured it out, but I didn't do it on this one, so just kind of bear with me on this. So we're going to combine these as reactants, and we're going to produce products. Trying to figure out what those products will be and whether one of them would be a precipitate or a solid. So we know that when we make a compound, it has to have a net zero charge. So remember when we've been doing the crisscross charges and they cancel out and we get the net zero because we have a cation and an anion in it. You have to have a positive and a negative to cancel them out for the charge. So what they've done here, what I did here is I kind of copied this. They wrote out the reactants that as separated ions. So let's look here. If you've got 2 potassium with a plus charge, it says it's aqueous. Where that came from was up here. This potassium, so it's K2 chromate, is aqueous. So if we are separating it to its ions, we have potassium, there are 2 of them. That should be a subscript, okay? We're just gonna have to go with it, is what it is right now. So that gets pulled out. Then the next one we have is chromate. Chromate is one of your polyatomics. So the CrO4 2-, which is also aqueous, because from the original part here, it was termed aqueous. Adding it to, now we're going to split apart barium nitrate. So we have barium has its 2+ charge, which is aqueous, plus if we look at the nitrates here, the NO3 2, there are 2 of the nitrates that have the negative charge, and that is also aqueous. These are going to produce products, but we're trying to figure out what they would produce. Okay, so they have this little chart method. I kind of copied it, and it's kind of, I don't know, kind of easy to follow. But what you're doing is you're taking everything that was separated out, and you're going to see the possible combinations of the cations or the anions. So the cations are here on the left-hand side. The anions go across the top. And we're going to combine them. So potassium combining with nitrate. See the plus and negative cancel out, so you get potassium nitrate with a net zero charge. You can combine potassium can be combined with chromate. See, there I have the superscript there and the subscript there. So we've got potassium chromate. Barium can combine with the nitrate, so you get barium nitrate. Or you can combine barium chromate and you get the barium chromate. We know from the original reactants that were in the equation that the potassium chromate and barium nitrate were already there. They already given as the reactants, right? So up here. So we don't want to look at those guys. We want to look at what's left. So what we have left to form the possible precipitate are the potassium nitrate or the potassium chromate. So let's take a look at our solubility table. This is from slide 17, and I copied and pasted it here. Look at the rules. Rule 1, all nitrate salts are soluble. Well, guess what? Look right here. We have potassium nitrate. We know that that one is not going to form a solid, right? Let's look and see, do we have anything that would be telling us about potassium chromate? We have chlorides, we have everything else here talking about it being whether it's soluble or not soluble. That one doesn't fall in. But the fact that we have one that's a nitrate kind of points to the fact that this chromate's going to be. Now, this is not a comprehensive list. There is a rule with the chromate, so we'll get into that later on, but just let's look at the process of elimination. So we know that the chromate is the one that would be the solid in the reaction. So there were several others that we listed here. We went through. So let's look at, on slide 19, we have potassium nitrate plus barium chloride. These are both aqueous solutions. If we separate them out into their ions, we have potassium, which is aqueous. We have nitrate, which is aqueous, plus the barium, which is aqueous, plus two chlorides right here, two of them that are aqueous. Do not forget, if you have a subscript there, it has to go back. Over here on the nitrate, you don't, because it's a polyatomic, right? So let's look at the possible combinations that we could have. We could have potassium chloride, we could have potassium nitrate, and barium chloride. So does a precipitate form? This is what we want to look at. So we're going to eliminate the two combinations that we know we already had as our reactants up here. Okay, so we don't have to look at the potassium nitrate. We don't have to look at the barium nitrate. We know that, we don't have to look at the potassium nitrate, and we don't have to look at the barium chloride. We do have to look with these two that are left. We have potassium chloride and we have barium nitrate are our two possible choices. So if you look at our solubility rules, potassium chloride, it says that all chloride salts are soluble. If you go back to that chart from page 17, slide 17, unless it's with silver, lead, and mercury. Potassium, therefore, is soluble, so that will not form a precipitate. So we're left with barium nitrate. So look at the first rule, all nitrates are soluble. Let's go back up here, look. The first rule, all nitrate salts are soluble. So guess what? No precipitate is gonna form here. The reaction's not gonna take place. It's gonna form two aqueous solutions, so we're not going to get a precipitate out of that reaction. Slide 20, we have sodium sulfate plus lead nitrate. We're going to break them apart, and I'm going through this on purpose because this is going to lead into us doing ionic and net ionic equations. I know some of you have already asked me about that. It's showing up in OWL, so this is going to lead into it. So get used to separating these guys out. So when you separate this out, you've got two sodiums, right? Na2 gives us two sodiums with a plus charge, and it's aqueous, plus sulfate, which is aqueous, the other part here, plus lead 2, right? Because that's the charge on lead. Over here, if you were on crisscross them, the 2 goes to the lead. And two nitrates, right? There are two nitrates listed there, and those are all aqueous. So our possible combinations that we could have here are sodium sulfate, sodium nitrate, lead nitrate, and lead sulfate. So we want to know, does a precipitate form? So we're going to do what we did before. You're going to eliminate the two possible combinations that are already there in the reactant, on the reactant side, okay? So on the reactant side, we can take out sodium sulfate. We know that that's not one of our possible products, and lead nitrate. That's also not a possible product. So that leaves us with the sodium nitrate or lead sulfate as possible choices. So we're going to look at the solubility rules. For sodium nitrate, remember rule 1, you'll get used to these. You won't even have to look this up anymore. But remember that all nitrate salts are soluble. So that one will not form a solid. It dissolves. So we're left with lead sulfate. So if we look at the fourth rule up here, and I copied it down here, it's most sulfate salts are soluble except for barium sulfate, lead sulfate, and calcium sulfate. Lead sulfate's one of the exceptions, which means that's actually going to form a solid. So yes, that precipitate will form. So when we rewrite the equation, let's do the whole thing down here. We've got sodium sulfate aqueous plus lead nitrate aqueous yields lead sulfate solid. This gets the solid because we know the precipitate's going to form, plus sodium nitrate, okay? And then I listed this one out here for slide 21 that I wanted you guys to try. But what we're going to do is try to do it together, and I'm going to try out my webcam. So bear with me on this one, but let's go out here and see if I can share it. This should be way better than what I was doing before. You can see my arm, sorry. So this is from slide 21. And what we have is potassium hydroxide, which is aqueous, and we're adding it to the iron nitrate, iron 3 nitrate, which is aqueous, right? So let's separate everything out. What do we get for the first part? Well, we know we have a potassium ion, which is aqueous, plus we have OH, that's one of our polyatomics, that's hydroxide, right? The OH minus, that's also aqueous. I know that because I'm taking the states of matter applies to both parts of what is written there in that compound, okay? Plus, we have iron. We know that iron has a 3+ charge. Look down here, remember if they uncrisscross, he gets the 3+ charge. That is also aqueous. And the other one that we have left there is a nitrate, but we have 3 of them. So we have 3 nitrates, which is also aqueous. So the nitrate has the 3, that means there's 3 of them total. So we're gonna put that as a coefficient in front. Okay, so our possible combinations, we could possibly have KOH, which we know we do, that was one of the reactants. We could have KNO3, which is potassium nitrate. We could have iron nitrate, which is one of our other ones that we already had. Or we could have iron 3 hydroxide. Okay, so let's cross off the ones that we already have as a reactant. We don't need those. Those aren't what we're going to be looking at. Okay, so that leaves us with potassium nitrate and iron 3 hydroxide as possible combinations that we could have. So let's look at the solubility rules. So for sodium nitrate, sodium nitrate? Potassium nitrate, sorry. All nitrate salts are soluble. I wrote it wrong on the sheet I'm reading off. Sorry. So all nitrates are soluble. So we know that this one is going to be aqueous. We know that that one is not going to form a solid. So we're left with iron 3 hydroxide. So the 5th rule on that one slide for the solubility is that most hydroxide compounds are insoluble, which means it will form a precipitate unless it's sodium hydroxide, calcium hydroxide, potassium hydroxide, or barium hydroxide. Iron hydroxide is not listed as an exception, so we know that that is insoluble, so we know that that is going to form the solid. So it will form a precipitate. That answers our question. And let's write out the full equation. I'll write out the entire balanced equation. So it's 3 potassium hydroxides, which are aqueous, plus iron 3 nitrate, which is aqueous, yields 3 potassium nitrates, which is aqueous, plus iron 3 hydroxide, which is a solid. Okay. All right, so I'm going to pause it for just a second and I'll come right back. Okay, so I'm back. I'm going to now go back to our PowerPoint. So if you guys have questions on what I just did, write them down, and you're going to have to probably email them to me, or I'm going to see if I can start like a chat room of questions or something like that. But let's take a look at what we have on the PowerPoint. So from our solubility slide, we've done that. These are the ones that we just went through. Okay, so what we have been doing when we're writing the aqueous reaction, so when we have the reactants and the products listed out, we have a complete molecular equation, okay? So look here, we've got potassium chromate plus barium nitrate yields potassium nitrate plus barium chromate, okay? And that's the solid that's produced. Shows us everything that's involved in the entire equation, but it still doesn't give us like the whole idea of what actually happened. So what we have to do is we have to show the ions in something that's called a complete ionic equation, which means what we were just doing before where I was separating things into ions, we're going to do that for everything in the equation except for the solid, and there's a couple other exceptions. We'll look at those as we go. Okay, so take a look at this. A complete ionic equation, all substances that are strong electrolytes, those are aqueous, they're shown as ions. Gases, liquids, and solids are not separated out. We're not going to break those up. So you're going to have to get used to what you're looking at, whether you've got a gas, a liquid, or a solid. We're only breaking up the aqueous solutions, so anything that has AQ next to it. So we can see, this isn't going to make sense right now, but what we're going to see is that here, now this is going to be a really hard one to explain, so I'm going to go through and explain it my own way, okay? So let's look at the equation without writing the spectator ions, okay? So when you write it without the spectator ions are going to make more sense in just a minute, because what they were showing here is they don't have the reaction here to show you. So this is like a little bit misleading. I'm just going to keep babbling for a minute until I can figure out what I'm trying to tell you guys. So yeah, I'm going to do it my own way, okay? I'm going to pause this and I'm going to write them on a piece of paper just so it makes a little bit more sense, okay? So hang on just a second. Okay, I'm back and I'm going to share the webcam again. I hope this is super entertaining for you guys. This is, I'm having fun. This is interesting. Okay, so I'm going back to my webcam. All right, let's see what we can do here, okay? So we've got something called a molecular equation, a complete ionic equation, and a net ionic equation, okay? The molecular equation, so let's just start one here. Let's do sodium chloride, my favorite, right? Which is aqueous, plus silver nitrate, which is also aqueous, yields silver chloride, which is a solid, plus sodium nitrate, which is aqueous. I don't know why I put that in parentheses. I just did, sorry, but it doesn't change it at all. This is the molecular equation. Okay, it tells us what happened. We want to break it down even further to try to figure out more of what happened. So we're going to write something that's called a complete ionic equation. And what we're going to do is we are going to separate out anything that has an AQ next to it. Anything that's aqueous is going to get separated into its own ions. So let's look over here. We've got sodium, which has a plus charge, and that is aqueous. Remember, the AQ applies to everything in that compound. Plus, we have chlorine, which is a minus, also aqueous. Okay. Plus, let's look at silver nitrate. Yeah, that is an aqueous solution. So let's take the silver, which has a plus charge, and it's aqueous. Plus nitrate, NO3 minus, is aqueous, right? Yields. What's on the other side of the equation? We have silver chloride, and that's a solid. We are not going to break that apart. We're just going to put it as is. And then we've got sodium nitrate. We can break that apart because that is aqueous. So we've got sodium is a plus nitrate. I'm going to run out of paper. I did it. And that's aqueous. Okay. That is called the complete ionic equation. The other one that we are going to be writing out is called a net ionic equation. Okay, let me separate these just so you know which ones we're talking about. Still going with the same top formula from the molecular equation. So in a net ionic equation, we're going to look at the solid. So look at the solid. We want to look at what reactants actually produced that solid as a product, okay? So which reactants actually participated in making the solid product? Okay, that's what we are interested in the net ionic equation. So let's write down our arrow and the solid that was produced, silver chloride. What was involved in making that? Let's look at our ions over on this side. Sodium was not involved. We don't see that listed here. Chlorine was involved. We have it over here. So we're going to list chlorine. Plus, let's look, silver. Silver was involved, right? So we're going to write down silver. And nitrate was not involved. We see no nitrates over here. They were not involved in making that. This is what's considered a net ionic equation. The little guys up here, the other ions that aren't listed, they're called spectator ions. The spectator ions are the ions, I gotta watch to make sure it's on the screen there. They're the ions that were not involved in making the solid product. Okay, think spectator like in a sporting game. Spectators watch. They watch the sports. We'll use sports here. They watch the sports. The participants, they are actually playing in the game. Okay, so if they're playing in the game, they're the ones that are making the solid. I'm running out of room on this sheet, you guys. This is funny. But you get the idea of what we're doing here, right? So the spectator ions up here at the top, so you have sodium is watching what's happening. Nitrate is watching what's happening. They were not involved in producing the silver chloride. Okay, so that is the basic idea behind writing a molecular equation, right? The full equation, reactants and products, balanced. A complete ionic equation where you're pulling everything out and separating it if it's aqueous. You take anything that's aqueous and you separate them into their ions, not solids or liquids or gases, just aqueous. And then we're going to look at the solid, what was produced up here, the silver chloride, right? And what actually produced it? Let's look at the ions. In the net ionic equation, we want the ions that produced it. We have chlorine and silver up here. The sodium and the nitrate are spectators. They're just watching. They aren't participating in the game, okay? I hope that makes some sense. I'm going to pause now. Okay, I'm back. This is fun, you guys. Okay, so let's do another one just to see, and then I'm gonna post some practice ones, and then I will post some answers to the practice ones. But I think this is something you just have to, again, look for a pattern on, right? So let's look at a molecular equation. Okay, I am going to have 3 potassium hydroxide, which is aqueous, plus iron 3 nitrate, which is aqueous, is going to yield iron 3 hydroxide, which is a solid, plus potassium nitrate, which is aqueous. Okay, so this is a balanced equation. This looks very similar to that other one we were working on that I'm looking back. Potassium, iron, 3 hydroxide. It is. So this is balanced. The other one was not balanced. So what we're going to do, I would like to write out a complete ionic equation. Okay. So we're going to pull apart into ions anything that has an AQ next to it. So we have to keep the 3 with the potassium. So we have 3K plus aqueous plus that 3 applies to the potassium. That 3 is a coefficient. It also applies to the hydroxide. So I have 3OH minus, which is also aqueous, plus we have iron. What is the charge on iron? We know it's a 3, which is aqueous. We have nitrate. How many nitrates do we have? We have 3. Okay, so far that's good. Now let's look at our product side. Iron 3 hydroxide is a solid. We're going to keep that all together. I'm going to run out of room. Plus, we're going to pull out, we have 3 potassiums, which is AQ, plus we have 3 nitrates. Remember that 3 goes to both? So we have 3 nitrates. Sorry, I had to write the aqueuses below. I ran out of room. I'm going to have to write smaller. Okay, so that's our complete ionic equation. For our net ionic equation, we want to look at the solid. What is our solid? Our solid is iron 3 hydroxide, right? We want to figure out what participated in making that iron 3 hydroxide. Did potassium? No, that is a spectator ion. How about hydroxide? Yes, we want to include the hydroxide. So we've got 3OH minus. Okay, what else? Did the iron participate? Yes, it did. So we have plus the iron. The nitrate is also a spectator ion, so we don't include that. Okay, so those are the 2 ions that made the product, the iron 3 hydroxide solid. So that's the net ionic equation. Spectator ions are potassium and nitrate, because they were just watching. They're just hanging out watching. Okay, so I'm going to stop the video here for this subject, and I am going to continue on a new video for other parts of chapter 7. Hope you guys are having fun with this. See ya.